You
Welcome
are
to
watching
Team
Team
ISP
ISP
Project.
Project.
Enjoy the
Enjoy the
video.
video.
We present to you simple pendulum experiment report. All credit to Mr. Albert to teaching us Physic 1. Assalamualaikum warahmatullahi wabarakatuh. Today we're gonna doing an experiment for simple pendulum. The objective of this experiment is to determine the relationship between the period T and the length of the simple pendulum L. So let's go and we start with theory. Many things in nature wiggle or vibrate in a periodic fashion. One such example is a simple pendulum. Simple pendulum is when we suspend a mass at the end of a piece of strings. Here, the to and fro motion represent a periodic motion. This oscillatory motion is called a simple harmonic motion, SHM.
It was Galileo who first observed that the time of a pendulum depends only on the length of the pendulum L. The time of this to and fro motion, called the period T, does not depend on the mass of the pendulum. Another factor is the acceleration due to the Earth's gravitational.
Longer pendulum has a greater period than a shorter pendulum. The period of oscillation in SHM for simple pendulum is ta-da!
So let's set up the experiment. The apparatus you have to need is bottle label with 15 gram and 100 gram and a measure thread 16 centimeters and a hanging place. Okay, let's go to procedure. The procedure is as show here. We have 5 steps. Okay, I'm gonna show you a video how we're gonna do this procedure. Okay, let's go to the first step of the procedure. Okay, as you can see in the video, the bottle is filled with water until it reach 15 gram mark. Okay, the second step is take a thread and tie the thread into the bottle that we just fill the water in. Okay, make sure tie the thread tightly and it's not loosened, so your experiment, the data will be accurate, more accurate. Test it before you tie it to the hanging place, yes, just like in the video. Okay, the third step is take the pendulum like we and tie it in the hanging place, just like in the video. As you can see, the guy tie it tightly. After that, he test it to make sure the pendulum doesn't fall off during the experiment.
Determine the time required for 10 oscillations of the pendulum with mass of 50 gram and then mass of 100 gram, respectively. Repeat the measurement 3 times and write the value in table 4.1.
We change the mass to the 100 gram. As we can see, the third video to the left, to the right, show the first oscillation time to occur is 1.74 seconds.
Measurement in table 4.2. Tie the slotted weight 50 gram at the end of the string and measure the time required for 10 oscillations at different pendulum length of 50, 40, 30, 20, 10 and 5 cm.
The first oscillation occur at 1.67 seconds. We only change the length of the thread to 14 centimeters. The first oscillation occur at 1.51 seconds. After that, we change again to the thread of 13 centimeters. Oscillation in the first video is 1.37 seconds. Repeat it with 20 centimeters of thread. The first oscillation occur at 1.31 second. Okay, after that we change the thread to the 10 centimeters length of the thread to 10 centimeters, and then we change the length of thread for the final time to the 5 centimeters.
Down the result in table 4.2.
Okay, first let's analyze this data. Okay, as you can see in your right, you have your data sheets. So, if you look at the data sheet, they are called period of isolations. So, you have to calculate that using the formula at the right above in the table 4.1. You can see T equals 2 pi z L per G. Use that equation to get the period of oscillations.
Here we have a graph. On the x-axis, we have a square root. On the y-axis, we have the period of oscillation in seconds. The blue dots represent experimental of data points collected from multiple tires using different pendulum lengths. The red dashed line is the line of speed, the best speed. This means the period increased linearly with the square root of the length. Conclusion hypothetical. If the experiment was successful, the graph of T square versus L would yield a straight line passing through the origin. The slope of this line would be calculated, and the experimental value for G would be determined. This experimental G would then be compared to the theoretical value of 9.81 ms squared to assess the accuracy of the experiment.
Okay, let's answer this question on this slide. It say, what if we replace plastic bottle with steel bottle, wooden bottle, and a lead bottle? Okay, to answer this question, we need to look at the question 4.1. As we can see, the oscillation period is not depends on mass. It depends on the length of the thread and the gravitational force by the earth. So, if we change the bottle with the same size but with a different mass, the time period is will be the same as they have the same size at the same length of thread.